Problem 4 of a simple band brake. Example 6.39. A simple band brake, as shown in the figure, is designed to stop the rotation of the shaft transmitting 45 kilowatt and a speed of 500 rpm. Selecting suitable materials, determine the dimension of the rectangular cross section of the band, dimension of the rectangular cross section of the brake lever, and diameter of the fulcrum pin. So this is the figure given. So the angle of lap theta is 225, diameter of the drum is 600. This means the diameter of the drum. So B is 300, A is 1000. So power N is 500 rpm, power is 45 kilowatt. A, B. Then first step is torque transmitted. So torque as MTD is 950,000 N by N. Substituting the values of 950,000 power and RPM, we get MT in Newton mm. So therefore, substituting the 950,000 N by N, we get 45. We get it as 8595 Newton mm. Now to find the actuating force, MT is F theta into R. So MT is known, R is known, F theta equals to. So MT equals to F theta into R. MT is known, that is just now we found it as, and R is 300, radius of drum is 600, so R is 300, F theta is 28965 newtons. Also now, so newtons. Also now we need to find the force, so the actuating force. So find the actuating force. So F and F, choose the maximum one to find the actuating force. Then, so therefore the forces are 382.31 newtons for clockwise rotation, for counterclockwise rotation, for that is 1.8141.81 newtons. So selecting maximum of these two, so maximum of these two is 2.8141. So keep it as it is now. Next, to find the width of steel band. So to find the width of steel band, we have the formula is W equals to T1 upon H sigma D. Now we have to find T1. How to find T1? We use this equation, MT equals to T1 minus T2 into R. MT equals to T1 minus T2 into R. So MT is known, R is known, therefore T1 minus T2 equation becomes 2865 newtons. Also T1 by T2 equals to e to the power mu theta. So T1 by T2 e to the power mu theta, mu is 0.3. If it is not given, assume it as 0.3. So it's not given, so assume mu is 0.3. Theta is 225 into pi by 180, you get a 3.242. Then T2 goes here, so it becomes T1 equals to 3.428 T2. So use this equation, substituting here this equation 1. So we get T2 equals to 4.4 newtons, and T1 equals to 4139.4 newtons. Substitute this T1 in the and H, thickness of band. So if they are not given thickness of the band, you can assume it as 0.005 D, diameter of drum, so it becomes 3 mm, that's 19.160. Therefore H equals to 3 mm. So therefore, and also assuming sigma D as 50 for the band. So assuming sigma D as 50, H as 0.005 D, and T1 is known, therefore W equals to T1 by H, W equals to 30 mm. Assuming rivets, the rivets punched in the band, 4 rivets 8 mm size in 2 rows. So therefore the new width will be W into 30 into 2 rows into diameter of the rivet hole, 8 mm size of the rivet, so hole has to be 9 mm. So 30 plus 2 into 9, that is 48, or adapted as 50 mm. The width of the band is 50 mm. Check for stresses. So crushing stress T1 upon I dH. So T1 4139.4 upon I is number of rivets 4, D is diameter of rivet 8, into H is thickness of the band 3 mm, that is 43, which is less than the assumed sigma D, and it is safe. Now dimensions of the lever. So dimensions of the lever, since allowable stress of the lever is not given, so you can assume it as C40 steel of FS3. So that is sigma Y, yield stress of C40 is 328.6 unit 10 book. So dividing these two, we get the allowable stress in the brake lever, that is 109.153 MPa. Now MB sigma max, F max into A, MB equals to Therefore sigma max mb equals to f max into a, that is 124,189 mm. Now in the bending equation, m by sigma b by c, I is b1 h1 cube by 12, assuming now h1 has 3 times the width. So b1 3 b1 cube by 12, 27 by 12, b1 4, and c as h1 by 2 instead of h. Substitute 3 b1 by 2 because h is 3 b1 by 2 because 1.5 b1. Substituting this, so sigma b is this, I is this, and sigma b, that is 109.53, and c as 1.51. So we get b1 as 19.625 or rounded to 20. Therefore thickness of the band break lever h1 has to be 60, 3 times the width. Now diameter of the fulcrum pin. So as we know that the tension T2 passes from here for clockwise rotation. So clockwise rotation, counterclockwise rotation, the T2 is this to T2, this T1. So now take the equilibrium of forces. So considering the vertical forces, so T2 cos 45 vertical force acting upwards plus positive, F5 is acting downwards so negative, so T1 is acting upwards so positive, F is acting downwards so negative. Substituting this, we get as F5 equals to 379.72 newtons. Now consider the vertical force for counterclockwise rotation. So counterclockwise rotation, so this T2 sin 45 this way and Fx other way, so therefore they both are opposite directions. So T2 sin 45 acts in this way, Fx is this way, so therefore Fx is 901.14 newtons. Therefore the resultant pin reaction of counterclockwise rotation, remember this counterclockwise rotation, Fr equals to square root of Fx square plus Fy square, located as 3904.14 newtons. Now considering for clockwise rotations, now consider vertical force. Now this becomes T1, this becomes T1, so T1 cos 45, Fy is downward force on minus negative, T2 is upward force plus, this becomes T2, and F is downward, so minus F. So substituting the values, we get Fy is 3819 newton. Considering horizontal forces, so this T2 is T1, so T1 sin 45 this way, Fx this way, so both opposite forces, so T1 sin 45 equals to Fx, so if Fx is 2927 newtons, and the resultant is square root of 2927 the whole square plus 3819 square, so it's 4811.74 newtons. Therefore so choose a maximum resultant pin reaction out of this two, this and this, so this is maximum, so the maximum reaction is 4811.74 newtons. Now assuming the pin as C40 steel, so sigma of allowable shear stress C40 steel is 109, and therefore allowable shear stress will be half of sigma, that is 54.765. Since the pin is in double shear, so maximum stress F max is 2 into pi by 4 dp equals to tau p. So maximum resonance stress is 4.42 into pi by 4 dp is diameter of the pin, the whole square into 54. Therefore diameter pin is 7.48, or it chooses to 7.5 mm. This is about the pin reaction and to find diameter of the fulcrum pin.